Hello viewers, this video lecture is for the subject Theory of Computation and we are going to see the topic Finite Automata with Epsilon Transitions. And the objectives are to understand the concepts of finite automata with epsilon transitions and to analyze the problems on FA with epsilon transitions. And previously we have studied about NFA, that is non-deterministic finite automata. The epsilon transitions are applicable only to NFA, which is not applicable in DFA. This type of automata also don't have auxiliary memory and can make more than one move on reading a simple. So here epsilon transitions means the system will perform the state transition without consuming any simple. So that case is called as empty null moves or epsilon moves. A system is moving from one state to another state without taking any input is called as null moves. It is otherwise called as epsilon moves. Such transitions are called as epsilon transitions. Now, the non-deterministic finite automata with epsilon transitions systems will perform two types of transitions, that is epsilon transitions and non-epsilon transitions. So epsilon transition means, already we told, the transition takes place without reading any input simple. Non-epsilon transition means, that is the normal case transitions, the system will perform the state change by consuming any input simple, by reading input simple. So these two types of transitions will be applicable in the epsilon NFA system. Now we are going to see the formal definition of NFA with epsilon moves. Here also we are having 5 tuples. M equal to capital letter M equal to M is the finite automata system. Non-deterministic finite automata system is defined as Q, it is the set of Q, sigma, delta, Q0, capital letter F. Capital letter Q is the finite set of states, finite states. Sigma is set of input simples, that is the same concepts that we have studied for DFA. Delta is state transition function. Here one variation is, normally the state transition function consists of 2 parameters. That is, first one is the current state. It is commonly called as capital letter Q, and second parameter is input simple. That means when we apply one input simple to one state, the system will produce the new state. That is commonly written as del of Q, and sigma tends to P of Q. P of Q is the new state. So this is delta function is for the NFA transitions, and for the NFA with the epsilon transitions, we can rewrite the delta function as del of Q into sigma union epsilon. That is, in case of epsilon NFA, we can have epsilon transitions or null transitions. So along with the input symbols, epsilon symbol will also be considered. Epsilon symbol will also produce the new state. So we can write del of Q into sigma union epsilon tends to, or it produces the new state P of Q. And Q0 is the initial state, capital letter F is the set of final state. Now we are going to see one problem, that is design NFA epsilon. We are going to design the NFA epsilon system and we will check for string acceptability. And the system is, along with the design of the system NFA, another one type of problem is the system will be given as the diagrammatic representation, and we have to draw the transition table and we have to check for the acceptability of the string. Here in this problem, the system is given, that is diagrammatic representation of the system is given. So from the diagram we can understand there are 3 states are there, Q0, Q1 and Q2. Initial starting state is Q0, final state is Q2, and we can see when apply A to Q0, the system remains in the same state Q0, and when we apply B to Q1, the system remains in the same state Q1. And the important thing is we are having the epsilon moves. So Q0 to Q1 having the edge labeled with epsilon means we should understand system is moving from Q0 to Q1 without consuming any valid symbol. So this transition is called as epsilon transitions. And also system is changing from Q1 to final state Q2 without consuming any valid input symbol. So this is also epsilon transition. So in such cases we have to mention epsilon in the edges, and we have to define the separate elements for the system, like what are all the set of states, capital letter Q, what are all the input symbol. So when we write the input symbols, we should care about sigma equal to, so valid input symbols are A, B, C. Along with that we have to include epsilon. And for the del function is represented with the help of the transition table. So we have to draw the transition table. In row wise we have to mention the set of states Q0, Q1, Q2. Column wise we have to mention the set of input symbols A, B and C. Along with that, one more additional column is needed to mention for the epsilon. So here epsilon is considered as one of the input symbol, and inside the cells we have to mention the new states by looking at the diagram. And we can see A is, when apply A to Q0, the new state is here the state is remains the same state Q0. B, applying B to Q0 is not applicable, not available, so we have to put phi in that place. And when we apply epsilon to Q0, we are getting Q1. When we apply epsilon to Q1, we are getting Q2. So in this way we have to fill up the transition table. So whenever a particular symbol is not applicable to particular state, we have to mention phi in that place. And after that, in these kind of problems, we have to consider another one concept, that is epsilon closure. Epsilon closure is used to identify all the states in the actual path which are formed with epsilon transitions. That is, we can write epsilon closure for a state. Epsilon closure for a state is the set of all the states reachable from the state without reading any symbol. So in our problem we are having three states, Q0, Q1 and Q2. For all the three states, first of all we have to define the epsilon closure. After that, while doing the problem, while checking for the string acceptability, we may need these values for the substitution. So initially we can write epsilon closure for Q0, Q1 and Q2 since we had only three states. So we have to find out the answer from the diagram. Epsilon closure of Q0 is actually the set of states starting from Q0, the set of states reachable by accepting the null transitions. So when we look at the diagram, we can see Q0, epsilon closure of Q0 is, and we have to find out what are all the sequence of states reachable by applying continuously the epsilon symbol. So epsilon closure of Q0 is Q0, Q1, Q2. Epsilon closure of Q1 is Q1, Q2. Epsilon closure of Q2 is same Q2 since Q2 is the final state. So initially we have to write these three things. After that we are going to check the string. Our string is ABC. So as like the previous problem, we have to apply one by one symbol, and in the right hand side we have to substitute the set of states from the table. We have to separate the delta functions, we have to perform the substitutions, and finally we will check for string acceptability. Initially we have to apply the input symbol A. So here del of, we have to do the problem in this way, del of epsilon closure of Q0, since Q0 is the starting state, we have to start with Q0, comma A. In the right hand side we have to substitute the set from the previously defined things, that is epsilon closure of Q0 equal to Q0, Q1, Q2. comma A. Then we have to apply A to the individual states. Like this, we have to combine the states by applying the union function. That is, we have splitted del of q0 comma A union del of q1 comma A union del of q2 comma A. So we have to apply the values from the table and applying union operation, finally we are getting q0. Similarly, in the next time we have to add one more symbol to our function a b. Now b is added. We have to do the operation in the similar way. Here epsilon closure of q0 comma ab will be expanded, will be written as del of epsilon closure of q0 comma a comma b. The inner contents are we found previously, so simply we can substitute this. So del of epsilon closure of q0 comma b. Epsilon closure of q0 is that we have to substitute from the previous definition q0 comma q1 comma q2 comma b. Then we have to separate it with the help of union operation. Del of q0 comma b union del of q1 comma b union del of q2 comma b. And when we substitute the values from the table, we will get some set of strings. And finally we have to add one more input symbol C. So our string is ABC, and in the same manner we have to perform the expansion substitution. Finally we are getting the state q2. Finally, after applying all the input symbols ABC, we are getting the state q2. Now we have to check the state whether we are getting the final state. Yes, since q2 is the final state, by applying ABC to our system, to our delta function, we are able to produce the final, we are able to reach the final state. Final state is otherwise called as accepting state. So hence we can tell the string is accepted. So in this way we may get the problems under epsilon closure or NFA with epsilon transitions. So for this topic we may get the university questions like define epsilon transitions with example program, and we may get the problems on epsilon transitions, epsilon NFA problems. Thank you all.